Hello students, in this session
Let us solve a question on torsion. In this question, it is given that a rigid horizontal rod of length 2L is fixed in a circular cylinder. Radius R is given to us. Vertical forces of magnitude P are applied at the two ends. The shear modulus for the cylinder is G is given to us, and Young's modulus is the E. The vertical deflection at point A we have to find out, right? So there is a horizontal rod, length of the rod is given 2L. So this is the length of the rod, that is the L plus L, that is 2L. It is attached to a shaft, this is the shaft, and a load P is applied at both ends, which is making a couple basically, right? And producing a torque, right? Due to this torque, there is an angle of twist. There is some angle of twist of this rod, right? There is some angle of twist in this rod. So we have to find out the vertical deflection of this point A. This A point will move slightly upward, right? So this A point basically will move upward. This A point, this will move upward due to this forces applied, and it is having some angle of twist. So this is the vertical deflection of this point A to A dash, and then there is some angle of twist theta, right? So we have to find out this A dash, the vertical movement of this point A in upward direction. This we have to find out. So let us solve this question.
in this question we have a shaft of length L which is fixed at this plate. By this plate it is fixed. Now a couple is applied. A couple is applied of force P and length 2L. Actually the length is 2L, L plus L, that is 2L. And due to this couple, this couple will try to twist this shaft. So there is a torque applied, and torque will be force multiplied by the perpendicular distance. The distance between two forces is 2L, right? So torque will be applied on the shaft, and due to this torque there will be angle of twist. There is twisting action on the shaft, angle of twist, and due to that angle of twist this A point will move vertically upward, move a slight distance, say YA. So we have to find out this deflection, that is YA, how much this vertical displacement of this A takes place due to the twist of this shaft, right? This we have to find out. So we can make a line diagram of this question like this, which is our conventional method of doing the things. This is the shaft, and a torque is applied, and this torque is equal to force multiplied by perpendicular distance, and that will be equal to 2P multiplied by L, 2PL, P multiplied by 2L. So this torque will be equal to, that is P multiplied by the perpendicular distance. So this is 2PL. This is our torque. Now due to this torque there is some angle of twist in the shaft. Say theta. So this is the angle of twist, and due to this angle of twist there is some vertical deflection in the shaft in vertical direction. So this point A will move vertically somewhat upward, right, due to that load, and we have to find out this deflection, right? This deflection due to that movement, right, due to this angle of twist. Say this angle is theta, and this is the force applied, and this A point moves now here. So we have to find out this deformation, this YA, right? So what will be YA? That will be equal to theta multiplied by the length L, right? We know S is equal to R theta. So this is theta because this length is L and this is vertical deformation. There is slight deformation, so curve we can neglect. So that will be equal to RL multiplied by theta. So YA will be given by L multiplied by theta, right? So we need theta now. Theta, what is the angle of twist in this case, right? So what will be the angle of twist? This we have to find out now, and multiplied by L will give the deformation of point A in upward direction, vertically upward direction, right? So YA will equal to L theta. So we have to find out basically angle of twist. So theta is given by, we know that conventional formula is there. Theta is equal to TL upon GJ. This is the direct formula, you should remember. Go to the chapter of torsion of circular shafts and find out that the angle of twist is given by TL upon GJ. So it will be given by T, torque, 2PL, 2PL, L is the length, G is the modulus of rigidity given to us, J is the polar moment of inertia, that is given by pi by 32 and d to the power 4, d to the power 4. So answer in radius, so d will be 2 times the radius, r is given, so 2r to the power 4, pi by 32, 2r to the power 4, right? From here we can solve it and get the value of theta. So theta will come out to be, solve it and get the value of theta. So theta will come out to be 4PL square, 4PL square upon r to the power 4. So this is the angle of twist. Solve it and you will get the answer. So the deflection at point A will be equal to a vertical deformation, that is L theta, right? So that will be equal to L can be multiplied here. So you will get 4PL cube by pi g r to the power 4. So this is the deformation of point A. So this is the answer and it is option D. Option D. So this is how we can solve this question.